Now come to what is ferrite. Okay, so we have discussed the ferrite. So here it is a austenite. Now we are going to discuss ferrite. So if you see, so austenite has the FCC structures, right? Now if we talk about the ferrite, in the ferrite, this is the BCC iron. So ferrite is a kind of the iron phase which is of having BCC with very limited solubility of carbon. So in ferrite, we cannot incorporate much more amount of carbon, though overall maximum efficiency is of only 6.67%, right? But if we talk about the ferrite, so it has a very less solubilities of carbon. Like austenite has a 1.8% of carbon, right? This phase may have other alloys element in substitutional solid solution. So here it is a interstitial, but here it is a substitutional. Substitution means the replacement of atoms. So whatever the atom that is going to fill in this, phase, that must be of the same size of, atomic size as atomic size of ferrite. Okay, or you can say of about iron. So like austenite, this phase has a sorry. Like austenite, this phase may have other alloying element in substitutional solid solutions. It is the name given to the pure iron crystal when are soft and ductiles. The solubility of carbon in ferrite is only 0.025%. You can think about maximum 6.67% is allowed, but here only 0.025% carbon is allowed at 7 to 3 degrees C. The slow cooling of low carbon steel below the critical temperature produces the ferrite structures. So slow cooling of low carbon steel means obviously it is a very low carbon capability. Okay, below the critical temperature, it is a cooling, right? If we are allowing to cool them, but it is a cooling is very slow, then below the critical temperature, the ferrite will produced. The ferrite does not harden when cooled rapidly. It is a very soft or highly magnetic. As you can see, it is at temperature below the 7 to 3 degrees C, right? And we have discussed when the 768, right? So below the 768, that is of magnetic nature. So obviously, the ferrite will also have a magnetic natures. Okay, so 91, just 910 degrees C to 768 degrees C. Only in this range, there is absent of magnetic nature. Otherwise, we will get a magnetic behavior of iron carbon mixtures or alloy, right? So here it is 723 degrees C. This shows that the cooling of carbon or low carbon steel below the critical temperatures produces the ferrite. Okay, it has a soft and highly magnetic, and obvious because this is below the 768 degree and sorry below the 768 degree. That's why it is a magnetic.